After an introduction like that, I'm going to adopt him. I'm grateful to be honored for my work in cancer, and I'm grateful to be a member of this distinguished group of four, myself not as distinguished as they, but that have been honored tonight. As is true in many aspects of nature, study of the abnormal and how it got that way can shed much light on the normal and how it stays that way. No one really understands what life is and how it evolves. From an acorn to a mighty oak is no less mysterious than transformation from a normal cell to a cancer cell. Understanding the cause of this abnormal life may well elucidate the mechanisms for normality. My colleagues and I pioneered combinations of 2 or more effective drugs to bring about the first systematic cures of childhood leukemia, and later, in a smaller proportion of the affected population, of acute leukemia in adults. We recognize the impact of a platinum compound on testicular cancer and the fungal product of doxorubicin on bone cancer in teenagers. These findings were used by other colleagues to formulate combination curative regimens of therapy for these diseases too. These examples constitute solid proof that many cancers can be cured by drugs, reinforcing the concept that cancer research is effective and that many diseases called cancer are not inexorably fatal. We are learning how to activate the body's own defenses against cancer cells, and the future is extremely bright. But in the 1990s, my attention turned to what causes a normal cell to become an abnormal cancer cell in the first place. It's been known since the 1930s, when Bittner described the fact that breast cancer in mice is caused by a virus, the mouse memory tumor virus. Early attempts to explore this possibility in humans failed because precise methodologies were not available. My colleagues and I have recently used the new techniques of molecular biology to find an absolutely unique segment of this virus in human breast cancer, and subsequently the entire human mammary tumor virus, which is 90 to 98% homologous to the mouse mammary tumor virus. Indeed, 40% of American women's breast cancers contain the human mammary tumor virus, and we have since proved that it's an infection and not an inherited genetic characteristic. Furthermore, it's well known that in Asia, breast cancer is much less common than it is in the Western world. It turns out that different species of mice occupy and are indigenous to Asia from those in Western Europe and in the colonies of Western Europe, including our own continent. Breast cancer in the United States is the commonest major cancer of women, although it's not the most fatal, which lung cancer is because of smoking. But mice contaminate our food chain and have contaminated our women ages ago. And the virus is passed in milk, just like the mouse. So one of the differences in the incidence of breast cancer appears to be related to differential rates of human mammary virus infection. We haven't proved that yet, that it's causal, but I'm committed to working until we do. This observation could provide an impetus to explore several other cancers whose causation is unknown. Many cancers in the animal kingdom are known to be caused by viruses. We are animals too. So if we prove the causation of cancers, it will be easier to prevent them and not wait for cancers to appear and then try to cure them. And I commend the Hope Fund for looking at basic science which can accomplish this with bright young minds committed to the task. Thank you.